Hello students. In this session we'll be looking into the first unit of IGCSE Physics, that is motion, forces and energy. We will explore the first subtopic, that is physical quantities and measurement techniques. So this is the syllabus for physical quantities and measurement techniques subunit. We have the core syllabus part and the supplementary syllabus part. For the purpose of this video, we'll be looking into the first two topics. The first topic being describe the use of rulers and measuring cylinders to find length or volume. And the second topic, describe how to measure a variety of time intervals using clocks and digital timers. So before we get into the topic, I want to impress upon you why measurements are important. So this is a incident which happened in 1999. NASA sent a satellite to Mars to study the climate over there. And this was a joint venture between Lockheed Martin and NASA. So Lockheed Martin used the imperial units and NASA used the metric units. So because of this, there was a mix-up in the software and it resulted into a big disaster with the satellite getting destroyed. So this is the importance of measurements and proper measurements being used with the proper units. So in measurements, we'll look at the first concept, which is parallax error. So parallax error is nothing but when an observer's eye is not positioned directly perpendicular to the scale of a measuring instrument. So like in this case, he is looking at an angle which is wrong, and looking at an angle is wrong. Looking perpendicular to the scale is correct. Secondly, in measurements, we need to know about the International System of Units, or the SI units. So the SI units is a set of 7 base quantities, but for our syllabus purpose, we are interested in the first 3 units, that is the unit of time, the unit of length and mass. For time, the SI unit is seconds. For length, the SI unit is meters. And for mass, the SI unit is kilogram. So the length measurement is done using 3 basic instruments, which is a standard ruler, a tape, and a trundle wheel. So the ruler is used for very small distances, which are of the order of millimeters to centimeters. And a tape is used for a little bit larger distances of the order of centimeters, tens of centimeters. And a trundle wheel is used for furthermore longer distances of the order of hundreds of centimeters. So the SI unit of length, as we saw, is meter, and length is also measured in centimeter and millimeter. We need to remember this relationship, that is 1 meter is equal to 100 centimeter, and which is equal to 1000 millimeters, and 1 centimeter is equal to 10 millimeters. So in this animation, we see how a trundle wheel actually works on what principle. That is one rotation. This rotation will start now at point C. This rotation is going to start. So we see that in one rotation of this wheel, one complete rotation of this wheel, from the point between C to D, it has moved a distance which is equal to the circumference of the wheel. The distance traveled in one rotation is equal to the circumference of the circle, which is nothing but 2 pi r, where r is the radius. So now coming into measuring volume. So for measuring volume, the primary instrument is a measuring cylinder. It is used to measure the volume of liquids. So here you can see measuring cylinders of different volumes, of different capacities. So volume is measured in as per SI unit in meter cube, and it is also measured in liters and milliliters. So here also we need to remember this relationships, that 1 meter cube is equal to 1000 liters and 1 centimeter cube is equal to 1 milliliter, and 1 liter of course is equal to 1000 milliliters. So these are certain regular shapes like a cube, a cuboid, a cylinder. So we have relationships, mathematical relationships to calculate the volume of these standard shapes like cube, cuboid, cylinder, sphere, and cone. But what do we do when we have irregular shapes like this piece of stone or some other irregular shaped objects? How do we measure the volume? So this is where we use the displacement method. So in displacement method, we find the object's volume by measuring the volume of fluid it displaces. So in this measuring cylinder, we have water filled up to a certain level. Uh, Initially, it is at a level of 24 centimeter cube or 24 ml. And when the rock or the irregular shaped object is put into this water, it displaces the water by a certain amount. The water level increases. And as we can see, the increased water level is 31 centimeter cube or 31 ml. So this difference in height, which is 31 minus 24, that is the volume of the irregular shaped objects. So once again, the volume of the irregular object is measurement after minus the measurement before. That gives us the volume of the irregular shaped object. And it's very important that when we are looking at the measuring cylinders, we need to look at the bottom of the meniscus. We shouldn't measure the top of the meniscus. Our eye level should be to be measuring the bottom of the meniscus. So based on what we have learned till now, let's attempt this problem. In this problem, this is a previous year question paper problem. Here we are given a figure and it is asked to calculate the diameter of one ball bearing. So this is a ball bearing, and this this is the center point, and this is the diameter of the ball bearing. So we have one, two, three, four ball bearings, and we are given the reading also. Here the reading is 4 centimeter, and here the reading is, at the end the reading is 12 centimeter. So we know this distance. This complete distance is nothing but 12 minus 4, which is equal to 8 centimeter. So 8 centimeter is the complete distance of 4 ball bearings. So when we divide this distance by 4, we get 2 centimeters, which is the diameter of one particular ball bearing. So the answer is 2 centimeters. Let's attempt one more problem. A student uses a ruler to determine the circumference of a wooden dowel. So this is a wooden dowel. She puts a mark onto the dowel, then rolls it along the ruler 3 times. So first time she has rolled, second time she has rolled, and third time she has rolled, before reading the position on the ruler at which it stopped. So at the starting, the reading is 1 centimeter, and we see that at the ending, the reading is 37 centimeter. So this distance is equal to 37 minus 1, which is equal to 36 centimeters. And it is rolled 3 times. So we need to divide 36 by 3, which gives us 12 centimeters. So 12 centimeter is the this distance. This distance is 12 centimeter. In one rotation, a wheel or a dowel moves equivalent to its circumference. So the circumference of the dowel is. Now we come on to the next topic, that is measurement of time. So to measure time, we use analog stopwatches or we can use digital stopwatches also. So just for information purpose, the standard human reaction time is 0.25 seconds. So it takes, there's a delay of 0.25 seconds because of human reaction time while measuring time. And we very well know that 1 hour is equal to 60 minutes and 1 minute is equal to 60 seconds. So now let's look at some problems. A stopwatch is used to measure the time taken for a runner to complete a lap of 400-meter track. The images below give the readings on the stopwatch at the start and the end of the lap. So we are asked to calculate how long it took the runner to complete the lap. Give your answers in seconds. So at the start, so here we need to be very careful about the units. So this digit, first digit is minutes, the second digit is seconds, and the third digit is 1/100th of a second. So let's write it down. At the start, it is showing 55 seconds and how much? 55 seconds plus point 10 seconds because it is 1/100th of a second. That is nothing but 55.10 seconds. And at the end of the lap, this is showing 1 minute and 45.10 seconds. So this 1 minute has to be converted into seconds. So 1 minute is equal to 60 seconds plus 45.10 second. So this gives us 105.10 seconds. So to get the difference between the end to get the difference between the end of the lap and the start of the lap, we just have to subtract 105.10 seconds minus 55.10 seconds. That gives us 50 seconds. So the answer is 50 seconds. So again, I'm telling be very careful about what are the units given. The first digit was minutes, the second digit was seconds, and the third digit was 1/100th of a second in this problem. So moving on to the next problem, we are given the time of a train entering station A and time it is entering station B. Calculate the time taken from the train entering station A to train entering station B and state your answer in seconds. So as I told, it is very important to look at the units. So here the first digit is hour, the second digits are minutes, and the third digit are seconds. In the previous problem we saw the first digit was in minutes, the second digit was in seconds, and the third digit was in 1/100th of a second. So here it is hour, minutes, and seconds. So we'll do the same thing. We'll just write it down in seconds. So first is 1 minute and 22 seconds, which is equal to 1 minute is equal to 60 seconds plus 22 seconds. This is equal to 82 seconds. And here it is 2 minutes and 34 seconds, which is equal to 1 minute is equal to 60 seconds. So 2 minutes is equal to 60 into 2, 120 seconds plus 34 seconds. So this is equal to 154 seconds. We require just the difference. So 154 seconds minus 82 seconds, we get 72 seconds. So the answer is 72 seconds. So with this, we finished the first two topics. We'll be looking at the further topics in the future classes.